Hi, so I'm going to go through question 1 part F on Mat 2008. So here it says, if the trapezium rule is used to estimate this integral by splitting the interval 0, 1 into 10 intervals, then an overestimate of this integral is produced. And then we need to figure out which of these 4 statements is true. Okay, so if we try and visualize this integral and using the trapezium rule, then, so say this is our function f of x, and we estimate it with some trapezia, and we have an overestimate, so these areas above our curve, the total of them is going to be greater than this area here where it's below the curve. But for an underestimate, we'd need the area below the curve to become greater than the areas above the curve. And I think the most obvious transformation which might do that would be the last one, because here we've got a reflection in the x-axis. So we'd have something looking like this instead. And we can see that by reflecting in the x-axis, then the bits which were above the curve now lie below the curve, and the bits that were below the curve is now above the curve. And so our overestimate has been turned into an underestimate. And the translation by 1 doesn't do anything, just shifts everything upwards by 1, and that doesn't do anything to these areas here. And so the answer for this question is actually D. And if we look at the other 3, so this first one is just a stretch. So it'll stretch all the graphs by a factor of 2 in the y direction. And so these areas will be doubled, but because we're changing all of the areas in the same way, the areas above the graph is still going to be greater than the area below the curve, so we'd still end up with an overestimate. And for this second one, we're just translating the whole thing down by 1, and so that's not going to affect these areas. And so we'd still get an overestimate by the same amount. And for the third one, we're just translating everything to the right by 1, but we've also translated the interval that we're integrating over to the right. So it's the same integral, it's just everything's been shifted to the right. So these areas are still going to be the same, and so these areas above the curve are still greater than the area below, and so we still get an overestimate. So indeed, the only one that gives us an underestimate is D.